Hi everyone, welcome back. In this video I will review over rules for significant figures. So all digits are significant except zeros used only to position the decimal point. Now make sure the measurement has a decimal point, then start at the left and move right until you reach the first non-zero digit. Count that digit and every digit to its right as significant. So for example here, we have a measurement of 0.0250 grams. We find the decimal point, and then we start at the left and move right until we reach the first non-zero digit. And I like to use a different color pen and underline it. So that's 1, 2, 3. We count that digit and every digit to the right as significant. So this is 3 significant figures, and I like to abbreviate significant figures as SF. Now if there's a decimal point, trailing zeros after non-zero significant figures are considered significant. So for example, we have 1, 2, 3, 4, 5 significant figures in this measurement. Because these trailing zeros come after the decimal point, they are deemed significant. In this second measurement here, in this example, we have 0.001250, so we start underlining here at that non-zero digit. 2, 3, 4, we have 4 significant figures. The third rule is that sandwiched zeros are significant. So if we start counting here at the left, 1, 2, 3, 4. This is 4 significant figures. If there is no decimal point, trailing zeros are not significant. Remember, they're only used to position the order of magnitude. So if we look at this one here, we start counting at 2 and then 5. But because there's no decimal place, we're not going to count these 3 zeros here. So this particular measurement is only 2 significant figures. This helps us, these zeros help us to determine that this particular measurement is 25,000 grams rather than 25 grams. So once again, these zeros are just placeholders to see the order of magnitude of this measurement. How many significant figures for this example here? Good, 3, right? 1, 2, 3. Remember, sandwiched zeros are also significant, but we're not going to count these trailing zeros. So this particular measurement has 3 significant figures. Now, all numbers in scientific notation are significant. So 1, 2, 3, 4. We have 4 significant figures here. All right, so the least certain measurement sets the limit on certainty for the entire calculation and determines the number of significant figures in the final answer. That's the whole purpose of learning how to report your answers to the appropriate significant figures. Many of you plan to become scientists, engineers, doctors, and you may publish some data or some results from your research. And you always want to report to the correct significant figures so that you tell the scientific community the precision of the tools that you used. And so that's why I'm a firm believer in going through these rules. It's very methodical and somewhat tedious, but once you practice them enough, it'll become second nature for you, and it's important you learn that early on in your career. All right, so let's do a very basic example here. So we have a sample that has a mass of 3.8056 grams and a volume of 2.5 milliliters. And a lot of times when I do word problems. I like to organize my data so I don't feel super overwhelmed by all the data that might be provided. So I write the given, and then I write what I need to solve for, just to organize my thoughts. And it looks like I need to calculate the density in grams per milliliter. And you would have learned a while back in first semester general chemistry, if not earlier, that density is mass over volume. And so then you plug in the numbers from the data. And I always like to include units so that I know what my final answers units will be. And if you plug in these numbers in your calculator, and I suggest that you do, you become familiar with your calculator, you would get 1.52224 and then grams per milliliter, the units for density here. But that's not the answer you would report. Let's come back here and look at our data. How many significant figures is the mass? 1, 2, 3, 4, 5. Good. 5 significant figures. How about the volume? Excellent. 2 significant figures for the volume. And so we report our final answer to the least certain measurement, which happens to be the volume. And we're going to talk about with multiplication, division, we report the final answer to the fewest sig figs. I'll go over those rules in a minute. And so the final answer here to the correct number of significant figures is 1.5 grams per milliliter. All right, so I've just alluded to the fact that there may be different rules for multiplication and division than there are for addition and subtraction. So let's look at this here. For multiplication and division, the final answer contains the same number of significant figures as the measurement with the fewest sig figs. For addition and subtraction, the final answer has the same number of decimal places as the measurement with the fewest decimal places. For example, if you have 1.25 grams plus 567 milligrams, and you're adding these together, remember when you add or subtract, make sure you're in the same units. And so right now we're in milligrams, and I didn't tell you what the final answer unit should be, so let's just say they will be in grams. So you have 567 milligrams. I'm going to convert that to grams. I'm a big believer in dimensional analysis. So how many milligrams in 1 gram? Good, 1,000. Excellent. Make sure to review over your prefixes so that you feel comfortable with conversions. So 1.25 grams plus 0.567 milligrams, if you plug that into your calculator or added it on your piece of paper, 1.817 grams. Now remember, we always need to round to the appropriate number of significant figures in order to tell the scientific community or our peers the precision of the measuring tools that we use. And so for addition and subtraction, we always report to the fewest decimal places. And so here, how many decimal places do I have for the first measurement of 1.25 grams? All right, I have 2 decimal places. And then here we have how many decimal places for 0.567? And my apologies, I meant to say 0.567 grams. But here for 0.567 grams, we have 3 decimal places. So we need to report to the fewest decimal places. So it looks like it will be 2. So your final answer here will be 1.82 grams. And I'll talk about why we rounded up here in a little bit. There you go. All right, the next example, we have 1.256 times 10 to the 20th meters over 5.23 times 10 to the 3rd seconds. And so if you plug that into your calculator, you would get this huge number with all these digits, 10 to the 16th, and your units would be in meters per second. Now this is division, and so we report our answer for division to the fewest significant figures. How many significant figures for the 1.256 times 10 to the 20th? You have 4 significant figures here. And for the 5.23 times 10 to the 3rd seconds, you have 3 sig figs. Excellent. So your final answer should be in how many sig figs? In 3. Good. 2.40 times 10 to the 16th meters per second. And there you go. Now the final example I wanted to work with you is this last one here where you have mixed orders of operation here. So you have 8.52 meters and 4.1586 meters. So these are added together in parentheses, so we'll do that first. Then you have 18.73 meters plus 153.2 meters. And then the final operation would be multiplication. Here. Promise that's an X. All right, so let's go ahead and do that. So if I plug the 8.52 plus 4.1856 into my calculator, I would get 12.6786 meters. Now it's really important that we do not round in the middle of the calculation. I actually do write down a lot of the digits here, but I look at the calculation here as is. So just treat it as one calculation. Like let's say that was the final thing I had to do here. It's addition. We report addition to the fewest decimal places. So it looks like 2. And so instead of rounding to 2 decimal places here, what I like to do is use a different color pen and underline. Say, okay, if I had to report a final answer here, it would have been reported to 2 decimal places. And I do the same thing for the other calculation here. So when I plug that into my calculator, I got 171.93 meters. I like to keep those units there. And once again, how many decimal places would you round to if you had to round at that point? Looks like you would have rounded to 1 decimal place. So use a different color pen and underline that decimal place there. Now the final order of operation is multiplication. And so you plug into your calculator this whole number multiplied by 171.93. So 12.6786 times 171.93. And you write down the number that you would get from it. So 2179.831698. And meters times meters is meters squared. Always include your units. Okay. All right. Now, multiplication is not to decimal places, but rather to the fewest significant figures. So, I look at my answers that I had written up here, and I ask myself, how many sig figs would they have been if I had reported them to the final answer? And it looks like it would have been 1, 2, 3, 4. And I will write that in my different color pen as 4 sig figs. Do the same thing for 171.93, and it looks like it would have been 1, 2, 3, 4 sig figs. So the fewest sig figs to report to looks like 4 significant figures. And so we need to round our final answer to 4 significant figures, so 2180 meters squared. And you may be thinking, well, hey, I see that there's a trailing 0, no decimal point. That's technically 3 significant figures by the way you've written it. The way we get around that is by adding a decimal point. Now that 0 is considered significant. So this is 4 significant figures. Now there's another way you could write this. You may feel more comfortable writing it in scientific notation, and this is a large enough number to do so. So you could have also written it as 2.180 times 10 to the third meters squared, because remember, all digits in scientific notation are considered significant. And there you go. Let's talk about the rules for rounding off. I've already shown you quite a bit through the examples. However, just want to summarize them for you. So if the digit removed is 5 or greater, the preceding number increases by 1. For example, 1.346, round to 3 significant figures. I'm going to round here. We're going to drop the 6. It's greater than 5, so the 4 turns into 5. Good. So this would be 1.35 grams. Excellent. Now, if the digit removed is 4 or less, the preceding number remains the same. For example, 244 milliliters rounded to two significant figures keeps the 4 there. So 2.4, don't round up, it's not 2.5, but 2.4. And we need to add a 0 as a placeholder. Now, a lot of times I will see students write 24 milliliters. They'll just stop right here because they're like, oh, it's 2 significant figures. And that's correct. But then they've lost an order of magnitude. You do not want to round 244 milliliters to 24 milliliters. So make sure, when you're doing your work, say it out loud and, ask yourself, does this number make sense? And I think you would catch it if you accidentally drop that 0. Okay. Also, you've heard me say this before, but I just want to reiterate, round off final answer only. Do not round mid-calculation. This introduces rounding error, and in second semester general chemistry, that can make a significant difference since we're working with small quantities. So be sure to keep digits on your calculator, keep track of significant figures or decimal places throughout using the trick that I just taught you in the previous examples, and then round at the very end. And then finally, exact numbers do not limit the number of significant figures in a calculation. Now, what I mean by exact numbers here, we're talking about things that you would count. You don't use a measuring tool like a mass balance or a graduated cylinder. You're just simply counting the items. So for example, if I told you I brought a dozen cupcakes to class, you would know that there are 12 cupcakes in that box, and you could count them. That's not a measurement. And so because it's not a measurement, we do not consider it as part of the significant figures. Only measurements do we consider significant figures when doing our calculations and reporting our final answers. So let's do a simple example here. The average mass of an M&M candy is 0.652 grams. What is the mass of 12 M&Ms? So let's write our given. So 1 M&M is equal to 0.652 grams. and it looks like we have 12 M&Ms. We need to find the mass, and we'll find it in grams, of 12 M&Ms. So we'll start off our dimensional analysis. I always start off dimensional analysis with the given information that is a single unit, so just 12 M&Ms rather than 1 M&M is equal to 0.652 grams. That's 2 different units. Okay. And then each of these M&Ms is equal to 0.652 grams. The beauty of dimensional analysis is that you can cancel out units, which is awesome. Your calculator would give you the number 7.824 grams. But always remember to think like a scientist and report to the appropriate number of significant figures. And so in doing so, I look at the given information here. So I look at, okay, 1 M&M, 12 M&Ms, 0.652 grams, and I notice that 1 M&M is an exact number because I can count it. 12 M&Ms is an exact number because I can also count those too. Therefore, they do not count towards significant figures. But 0.652 grams is a measurement. That's something I would need to use a balance for. And so that is 0.652 grams. Now, some balances can give to 4 decimal places and therefore would be more precise. Some give only to 2 decimal places and therefore would be less precise than the measurement provided here, right? And so that's the reason why it's really important that we report to the appropriate number of significant figures, as I've mentioned before, is that we all have different measuring tools, and we need to tell the scientific community and our peers specifically what type of tool we used and how confident we are in our results and certainty. So with that said, we need to round to 3 significant figures. What should your final answer be? 7.82 grams. Excellent. All right, that wraps up our conversation on the rules for significant figures and working examples. Thank you for watching and see you next time.